Hello friends, we are continuing our next topic in the second unit is contouring, right? Contouring means, are you able to see the background of this slide? There are some continuous parallel lines, right? Can you guess what it is? With the title you can guess it is contour, but what it is? There is number 1800, 1950, 1200, 1050, something. Somewhere else, somewhere it is round, it is continuous. What they are, how it was drawn, what it represent. So that you should know. Somewhere else it is very too close. Somewhere it is free space. Somewhere it is equally splitted. Right. So these things, how it was made, how it was drawn, and what it represents, right? That we should know, right? The closed lines are represented as steep slopes. If there is a hilly terrain and it has a steep slopes, the steepness have elevational difference, very minute changes, so that is represented with very closed thing. And there is empty space area that is flatter with only a gentle slope, right? So the contours are those lines you can see on OS maps, that is ordnance map. A contour line, and it is an imaginary line. Just remember, it is an imaginary line of the earth terrain. The earth won't have these lines, but we can represent the earth with these lines that joins points of equal height or elevation above sea level. They can be used to learn about the shape of the land, that is relief. A map with only a few contour lines will be a flat, that here it is represent flat, and often low lying, it is normal terrain, right? If a map has lots of contours, it is a mountainous or hilly terrain, right? You can see here. The actual pattern of lines will tell you more detail about the area too, right? How the terrain is slopey terrain, normal slope, flat terrain, it is a continuous slope terrain, or it is a rugged terrain, it is a ups and downs terrain. Everything, the contour will show how the terrain is. So the actual pattern can be obtained based on the surveying data, that is leveling. If you are doing that elevational values, if you try to draw it, the pattern can be obtained. So contour, an imaginary line on the ground surface joining the points of equal elevation, is known as contour. That is the one of the definition. Other words, contour is a line in which the ground surface is intersected by a level surface obtained by joining points of equal elevation. The equal elevation points are joined. These lines on the map represent a contour and is called a contour line. And the map showing contour lines is known as contour map. The contour map gives an idea of altitude of the surface, features as well as their relative position in plan, serves the purpose of both a plan and a section. So the process of tracing contour lines on the surface of the earth is called contouring. So the main purpose of contouring is contour surveys carried out at the starting of any engineering project, such as a road, a railway, a canal, dam, a building, etc. For preparing contour maps in order to select the most economical or suitable site, contour map is required. To locate the alignment of a canal so that it should follow a ridge line. What is ridge? Ridge, valley. Ridges means the top edges of the hill. Valley means the bottom deep line of the hill. So the ridge line has to be followed. to mark the alignment of roads and railways so that the quantity of earthwork both in cutting and filling should be minimum. These are the purpose, and this we can see at the end of the contouring topic in the uses of contouring with figures also, right? For getting information about the ground, whether it is flat, undulating or mountainous, the contour map is drawn. To find the capacity of reservoir and volume of earthwork, especially in the mountainous terrain. To trace out the given grade of a particular road. To locate the physical feature of a ground such as pond, depression, hill, steep or small slope. Everything can be obtained by drawing those contour maps, right? Again we repeating the definition. From here onwards the slide which you are going to see with the help of the NPTEL website, we are using most of the images, so that reference I have shared here, you can also use that website for your reference, right? The NPTEL belongs to the IIT. The line joining points of equal elevation is called a contour line. It facilitates depiction of the relief of terrain in a two-dimensional plan or map. So this is the standard definition, you can have it, right? The two terms you have to remember: contour interval, horizontal equivalent. Then what is contour interval? The difference in elevation between successive contour lines. Successive contour lines on a given map is fixed. That is contour interval. While drawing the map itself, we are joining the equal elevation in a single line. Next line may be different elevation, but those equal points will be joined. The gap between those two, predominantly we try to make it same, fixed. This vertical distance, any two contour lines in a map, is called the contour interval. It can be represented CI, right? The contour interval. Here the 74 represent the elevational value 74 meter and 73 represent the 73 meter elevational points, and those joined lines contour line. So the difference here is 1 meter, right? So figure 17 shows a contour interval of 1 meter, whereas here the contour interval is 10 meter height difference, that elevational difference. The choice of suitable contour interval in a map depends upon four principal considerations. What are they? Depends upon the nature of the terrain, what type of terrain, and based on the scale of the map, whether it is small scale, it is a large scale or a medium scale, right? And accuracy of requirement and time of cost, how much cost can be procured or it can be involved. Based on that only the contour interval can be chosen for drawing the contour map. Then what is horizontal equivalent? The horizontal distance between 2 points on two consecutive contour lines for a given slope is known as horizontal equivalent. For example, we will see the figure having contour interval 10 meter. Similarly to this, the horizontal equivalent in the slope of 1 in 5 would be, so 5 product gives the 50 meter the horizontal distance. So thus horizontal equivalence depends upon the slope of the ground and required grade for construction of a road, canal and contour interval. Then what is the representation of it? 17.1b. here, right? The contour interval can be fixed based on 4 factors we have seen in the last slide. First one is the nature of the terrain. So if we want to draw the contour interval or contour map for the purpose of building site, and the scale most probably it is 1 in 1000 or less than that, so the contour preferable is 0.2 to 0.5. If it is for a town planning more bigger than this, or a reservoir, the scale varies from 1 in 5000 to 1 is to 10,000, and the contour interval can be maintained from 0.5 to 2 meter. Or to locate location of survey, earthwork, etc., it can go up to 1 is to 10,000 to 1 is to 20,000, and the contour interval we can maintain is 1 to 3 meter. So the contour interval depends upon the nature of the terrain. For flat ground, a small contour interval is chosen, whereas undulated and broken ground, great contour interval is adopted. Right? It depends upon the nature of the terrain. Next, based on the scale of the map, a contour interval normally varies inversely to the scale of the map. If the scale is small, the contour interval will be more. Right? So the large scale, it is 1 is to 1000, it is small scale 1 is to 10,000. For the large scale map, based on the type of terrain, if it is a flat terrain, the contour interval will be 0.2 to 0.5. For the same small scale map, the flat terrain, it is 1 to 3 meter interval. Right? So these difference you have to remember, or you have to understood. Right? And based on the accuracy need of surveying work also decide the contour interval. Surveying for detailed design work or for earthwork calculation demands high accuracy, and thus a small contour interval is used. But in case of location survey, where the desired accuracy is less, higher contour interval should be used. And based on the time and cost, if the contour interval is small, greater time and funds will be required in the field survey, in reduction and in plotting the map. If the time and funds available are limited, the contour interval may be kept large, and we can complete the work very fastly.